Hello and welcome back. In this lecture we'll start setting up a project from scratch. We'll use NPM as the main build tool, TypeScript as the compiler, and Webpack as the module bundler. So in a terminal or command prompt if you're on Windows, let's start by creating a new folder. Let's call it Angular 2 Starter because it's a project you can copy and reuse as a starting point for new Angular 2 applications. Let's go into that new folder and open it in an editor. Right now it's just an empty folder, of course. So where do we start? Well, it's a web application, so we'll certainly need an index.html file. We also know that we'll need a build step, and it's a good idea to keep all our source files in a separate folder. So let's create a source folder. And inside source, we can create the index.html. Now I'm going to paste the HTML code for a basic web page here. There's no point in typing all this manually. You can find the same code in a text file available as a resource for this lecture, so please go and download it now if you want to follow along. Anyway, we can set the title to Angular 2 Starter, and then we'll need a custom tag where we want to insert our root Angular component. Let's call it My App for this example, and put some loading text inside it to be displayed before the app is initialized. Right, so next we'll need to write this Angular component as usual, but this time let's keep all our application code in a subfolder called app, and here we can add our app.component.ts. So in this file we need to import component from Angular core, but now we have a problem. The Angular core module doesn't exist in this project. So at this point we need to start using NPM to download all the Angular modules. To use NPM in this project, we need to create a file named package.json. It's a JSON file, so it will contain a JSON object, and like the editor suggests, we need at least two properties here, name and version. So the name of our project is Angular 2 Starter, and the version we can set it to whatever we like really, but let's start with 0.1.0. This is now a valid package.json, but it's not very useful yet. What we really want is declare our dependencies. So dependencies is another JSON object that contains name and version of each dependency. Like with the HTML code, typing everything manually is not really worth it, so I'm going to copy and paste all the Angular dependencies from the text file you can find in the lecture resources. But let's go and analyze them one by one, since we haven't really done this before. We have a bunch of Angular modules. We know about Angular core, that's the one we were trying to use to import the component decorator. Platform Browser Dynamic is the one that contains the bootstrap method, at least in the version I'm using. In the next Angular release, Platform Browser Dynamic will actually be merged into Platform Browser, so you'll no longer see Platform Browser Dynamic, you'll just import bootstrap from Platform Browser. HTTP, we used it in the last section. Then we have common that we haven't used directly, but is required by the other Angular modules anyway. Compiler is needed for compiling the templates that we write in our components. We haven't used the router yet, but we'll look at it in a future section. Basically, you always need all these Angular modules except for HTTP and router that are optional. You only need HTTP if you make HTTP requests, of course, and router if you use routing, but there's no harm in including them here even if you don't actually use them in your code. Then we have a few other packages that are not part of the Angular project itself, but are prerequisites for running an Angular application. Let's start with core.js. On the npmjs.com website, we can search for any package, so if we enter core.js, we'll be taken to the project description. Basically, Core.js provides ES6 support for those browsers that don't yet support all the new ES6 features. Now, you may think, wait a minute, the TypeScript compiler already takes care of converting our TypeScript code into ES5 code, so why do we need this Core.js package as well? The point is that ES6 introduced new syntax features, but also new objects and methods to the standard library. Things like arrow functions or backtick strings are syntax features, and the TypeScript compiler will convert them into ES5 code. But things like promises or new methods like string repeat, they're not about syntax, they're part of the standard library. In ES6, promise is available as a global object, so Core.js provides all these new objects and methods for browsers that don't have them already. Libraries like Core.js that provide support for a new standard to old browsers are usually called polyfills or shims. Core.js is not the only option. We could use ES6 shim instead, for example. That is another project with the same goal. The Angular documentation recently switched from ES6 shim to Core.js because Core.js apparently works better on some versions of Internet Explorer. The next package is reflect metadata. So if we search for reflect metadata on npm.js, it says it's a polyfill for the metadata reflection API. It's not worth going into details, but basically it allows Angular to use the metadata we pass to the component decorator, for example. Then we have RxJS that we've seen in the last section because it's used by the HTTP client. RxJS provides observables that are also used by other pieces of the Angular framework. Finally, we have Zone.js. Let's search for it in the NPM registry. He says it implements zones for JavaScript, but what is a zone? If we scroll down a little bit, here he says that a zone is an execution context that persists across async tasks. Now, this library was created by the Angular team specifically for Angular 2, but it's a separate package because it can be used without Angular as well. What it does is basically allow Angular to know when an asynchronous operation completes so that Angular can trigger its change detection. It's a bit of an advanced topic, but if you used AngularJS 1 in the past, you probably know that in some cases, like if you used an async function such as setTimeout, you had to manually tell Angular to perform change detection by calling scope apply, for example. With Angular 2, this is no longer needed, and that's thanks to Zone.js. Anyway, you generally don't need to deal directly with these libraries. You just need to remember to include them as dependencies. So now that we declared all these modules, we can go back to our terminal, type npm install, and this will download all those packages. It shouldn't take long because they don't depend on many other packages. So now, if we go back to the editor, we can see this node modules folder that contains exactly the packages we declared as dependencies. Each package has its own subfolder, except for the Angular modules that are all grouped under this @Angular folder. So if we close all the files and reopen our app.component.ts, the Angular core module is now available, so it's no longer showing an error. And we can finish creating our component. Let's write @component as usual, passing the metadata with a selector property that we need to set to myApp to match what we put in index.html, and then a template string that can be a simple heading showing myApp as the title. Then we need to export a class named appComponent that we can leave empty. Good. Now the editor is actually showing an error, but that's just because we are using decorators and we need some TypeScript configuration to enable the experimental decorators feature. We'll do that later. Now let's go and add a main.ts file to bootstrap our application. I'm going to put it at the same level of index.html just to keep the structure similar to the one generated by the Angular CLI. Here we need to import the bootstrap method from Angular Platform Browser Dynamic, even though from the next release it will be in Platform Browser instead. Then we import our app component that relative to this file is in app/app.component because it's inside the app subfolder. And finally, we bootstrap app component, and that's it. So we have all our TypeScript code, but we cannot use it yet. We now need the TypeScript compiler to generate ES5 JavaScript code that we can actually load into the browser. We'll do that in the next lecture. I'll see you later.